Welcome back to Cloud Concepts on the Run. For those just joining, I'm Tim, and I'm your guide through the world of AWS.
And I'm Andy. We're so glad you're tuning in again. In our first episode, we covered, the absolute basics.
Right.
But today, we're ready to take the next step.
That's right. In episode 2, we're going to continue our journey with EC2,
Okay.
but with a focus on strategy. We'll explore some really smart ways to save money just by changing when and how you scale your servers, up and out.
And we're finally going to start digging into some of those core networking concepts in the cloud.
Yeah.
It's the plumbing, right? The stuff that makes everything else work together.
Exactly. I mean, think of this episode as building the essential framework.
Okay.
It's going to prepare us before we introduce you to a whole bunch of other amazing AWS services that we haven't even talked about yet.
It's the foundation you need to build anything powerful.
Totally.
Ready to lay the groundwork? I am ready for our next lesson, but I have a feeling you have something else planned first.
You know me too well. I have to start with a question.
Okay, hit me with it.
Why did the cloud server break up with the on-premise server?
I feel like I should be bracing for impact here. I don't know, Tim. Why?
It just felt like it needed more space.
That is so wonderfully cheesy. All right, joke delivered. Let's get to work. What are we scaling today?
I love the enthusiasm. Okay, before we get into scaling, let's do a quick, a 15-second recap. In our last episode, we talked about EC2 instances, our virtual servers, and security groups.
Right.
And those security groups act as the bouncer or, the firewall for those instances.
Right, the bouncer at the door of the house. And we mentioned that when you launch that EC2 instance, you have to choose where in the world it lives, which AWS region.
Yep.
And that choice, it really matters.
Oh, it matters immensely. You want to place your instances in a region that's close to your users for low latency.
Okay.
Or maybe in a specific country to comply with data sovereignty laws. It's a very intentional first step.
Okay. So let's say we've intentionally placed our server in, say, the Oregon region, but our website gets featured on a popular blog, and suddenly our one little server is just overwhelmed with traffic. What do we do?
This is where we get into the magic of cloud scaling, and we have two main ways to do it. We scale up and we scale out.
Let me guess. Scaling up is like swapping the engine in your car for a much bigger, more powerful one.
That is a perfect analogy. Vertical scaling or scaling up means you stop your EC2 instance and you change its type to one with more CPU, more RAM, more power.
Right.
You make the one server a bigger beast.
And scaling out, that must be horizontal scaling. Instead of getting a bigger car, you just add more identical cars to your fleet.
Exactly. You go from one server to 10 or 100 servers all working together behind a load balancer to handle the traffic.
Wow.
And for the exam, this is the most common and flexible way to scale.
But who's watching the traffic to know when to add more servers? I mean, I can't be sitting there at 2 a.m. on a Saturday waiting to click a button.
And you don't have to. That's where auto-scaling comes in. You create something called an auto-scaling group, or ASG.
An ASG.
Think of it as the smart manager for your fleet of servers.
So this ASG manager, what does it do?
So you give it a set of rules. You say, okay, I always want a minimum of 2 servers running. If the CPU usage goes above 70% on my fleet, start adding more servers up to a maximum of 20.
Okay.
And then if the CPU usage drops below 30% for a while, start removing servers to save money. The ASG handles all of that automatically.
And I bet it does more. What if one of those servers just crashes?
The ASG's health checks will detect that. It'll automatically terminate the unhealthy instance and launch a brand new, perfectly healthy one to take its place.
Whoa!
Without you lifting a finger. That is a core concept for building resilient applications.
That is genuinely powerful. So we're automating our scaling. Now, you've mentioned this is more of a solutions architect topic, but what are placement groups? It sounds like we get even more control over where these servers go.
You do. This is leveling up your knowledge. A placement group gives you control of the physical placement of your EC2 instances within an availability zone.
Okay.
There are a few types, but let's focus on
two opposites, cluster and spread.
Cluster. Sounds like they're all huddled together.
They are. A cluster placement group puts all your instances on the same physical rack in the data center. The benefit?
High speed?
Extremely low latency and high-speed network communication between them. Think of a high-frequency trading application where every microsecond counts.
But the risk is obvious. If that one rack of hardware fails, your entire application goes down.
Precisely. So for the opposite scenario,
Let me guess.
you use a spread placement group. This guarantees that every single EC2 instance in the group is on a different physical rack.
Ah, so if one rack fails, you only lose one server. You're spreading the risk.
Exactly. It's the ultimate trade-off. Do you need extreme performance or extreme reliability? Placement groups let you make that choice.
Okay, this is making sense. We've talked about scaling within one region, but, sometimes big companies have resources all over the world. How do they connect their different private cloud environments, say their VPC in Ohio with their VPC in Ireland?
Another great solutions architect level question. The answer is a feature called VPC peering. It's a networking connection that lets you link two VPCs together even across different regions.
Really?
Yeah, and it makes them behave as if they are on the same private network.
So the servers in Ohio can talk directly to the servers in Ireland without having to go over the public internet.
Exactly. It's secure, it's fast, and it's how you build a truly global interconnected private network in the cloud.
Wow.
You don't need to know the deep technical details for the practitioner exam, but just knowing that VPC peering exists and what it's for is a huge plus.
This really feels like we're moving from individual Lego bricks to building the entire Lego castle.
That's the goal. Understanding how these services connect is what separates a practitioner from an architect.
Now, here's a question we'd like you to think about. The core idea of autoscaling is automatically adding resources to meet demand. If you could apply this auto-scaling principle to one area of your personal life or work, what would it be and what would you use as the trigger to scale up?
So Tim, last time we dove into the magic of scaling our EC2 servers to handle, huge spikes in traffic. It's fantastic to have all that power available on demand.
It is, but just like with any utility, on demand is the premium price.
Right.
It's the most flexible, sure, but also the most expensive way to pay. So today, I think we should flip the coin and talk about how to be strategic and save a significant amount of money in the cloud.
I love that. So I can rent a supercomputer for a few hours, which is great.
Yeah.
But what about the other side of that? What if my company has like a main website that I know is going to run 24/7, 365 days a year?
Okay.
Paying that high hourly on-demand rate forever, that just seems inefficient.
That is the perfect use case for a pricing model called reserved instances, or RIs.
Okay.
The best analogy is a real estate lease. Instead of paying the high nightly rate at a hotel, you sign a 1 or 3 year lease on an apartment.
Right.
You tell AWS, look, I commit to using this specific type of server for a long term, and in return, they give you a huge discount, up to 72%.
A lease agreement? That makes total sense. You're trading some of that on-demand flexibility for a much better, predictable price.
Exactly.
And you can choose to pay for that lease all up front for the biggest discount, or just have it added to your monthly bill, right?
Exactly. And the flexibility doesn't stop there.
Oh,
Let's say your business plan changes.
okay.
There is even an RI marketplace where you can sell the remainder of your lease to another AWS customer.
A marketplace for server capacity? That's wild. Okay, so RIs have my steady, predictable workloads covered.
Yep.
Now, let's go to the complete opposite end of the spectrum. What if I have a task that requires an enormous amount of compute power, but I have absolutely no deadline? It can happen tonight, tomorrow, over the weekend. I just don't care when.
Now you're talking about my absolute favorite cost-saving tool, spot instances.
Okay.
This is where you get to bid on AWS's spare, unused computing capacity.
Wow.
It's the definition of a win-win.
Yeah?
AWS makes money on servers that would otherwise be sitting idle, and you get access to them for a massive discount.
That's great. Let me try an analogy for that one. Is it Is it like flying standby on an airline?
Go for it.
I might get a seat for 90% off, but I also accept the risk that if a full fare passenger needs that seat, I'm getting bumped.
That is the perfect analogy. You can save up to 90%.
Wow.
But you have to design your workload knowing that AWS can take that server back with just a 2-minute warning.
So this would be incredible for tasks like a movie studio rendering a complex 3D scene overnight.
Yep.
Or with the explosion in AI, I imagine this is perfect for training a machine learning model.
Exactly.
Which is a massive, time-consuming task that can often be paused and resumed.
You've nailed the exact use cases. You would never run your primary customer database on a Spot instance.
Right, of course.
But for those interruptible background jobs, it's an absolute game changer.
Okay, so a big company is now using a mix of all these pricing models. They have RIs for their database, on-demand for their web servers that autoscale, and Spot fleets for data processing.
Right.
This sounds like it could get organizationally chaotic really fast.
It can.
How do you prevent the marketing department from accidentally running up a huge bill on the company card?
That is a very real problem.
Yeah.
It's solved with a service called AWS Organizations.
Ah.
It allows a company to create a master account that governs many sub-accounts.
Okay.
Each department, marketing, development, production, gets its own account.
So it's like a corporate headquarters managing its branch offices.
Exactly.
HQ, the master account, gets one single consolidated bill, but it can still see exactly what each branch is spending.
Right.
And I assume it can also set rules like preventing the dev branch from touching anything in the production branch.
Precisely. It provides both financial clarity and crucial security guardrails.
Okay.
And this leads to a really important truth. Moving to the cloud does not automatically save you money. You can save a fortune by only paying for what you use, but you can also waste a fortune by paying for resources you've forgotten about.
And that's why you need a plan.
Right.
A blueprint for how to build things the right way.
Exactly.
And AWS gives us that blueprint.
Oh, yeah? It's called the Well-Architected Framework.
Okay.
And it's built on 5 pillars.
Okay.
Think of these as the 5 core principles you should have in your mind whenever you design anything in the cloud.
Okay, let's list them off.
Tim, first, operational excellence. Then, security. Third is reliability. Fourth is performance efficiency.
Okay.
And last, but not least at all, is cost optimization.
So it's a checklist for success. Are you automating your operations? Is your system secure? Can it recover from failure? Is it using resources without being wasteful?
Mm-hmm.
And is it financially efficient?
You've got it. As a solutions architect, your job is to constantly balance those 5 pillars to build the best, most robust system possible for the business.
Right.
It's the framework that guides every decision.
And now, here's a question we'd like you to think about. The well-architected framework is about balancing 5 key areas. In your own work or personal projects, what are the 2 pillars you find yourself focusing on the most? And is there one you tend to neglect?
Okay, Tim, so we've covered a lot of the high-level administrative stuff.
Yeah.
Which is, very important. But you promised me today we'd take a little break from that and get nerdy. Let's talk networking.
I am so ready to get nerdy. Let's do it. We've thrown around the term VPC a lot, but today we're going to take a much closer look under the hood.
VPC, Virtual Private Cloud. I'm sticking with my favorite analogy for this one. It's our private, fenced-in plot of land within the huge city of AWS.
It's the perfect analogy.
Right.
And it sets the stage perfectly for our first topic, addresses. So every house on that plot of land needs an address.
Okay.
And in a VPC, our EC2 instances, they get 2 kinds.
Right.
An internal IP and an external IP.
Okay, let me take a shot at this one. The internal IP address is for communication within our private neighborhood, right?
Mm-hmm.
Like one of my application servers talking to my database server.
Exactly. That traffic is fast, secure,
Right.
and it doesn't need to traverse the public internet. It stays safely within your fence.
So the external or public IP address is the house's official mailing address for the rest of the world. It's how people visiting my website find the right server to talk to.
You've got it. But this is where we hit a critical concept.
Uh-huh.
And it's tied to what happens when you stop and start your EC2 instance.
Oh.
Now, this is a behavior that trips up almost everyone when they're starting out.
All right, I'm listening. So I go into the AWS console, I stop my server to save money over the weekend,
Yep.
and then I start it again on Monday morning. What happens?
Okay, so when you stop an instance, you're deallocating the underlying physical hardware.
Okay.
You're doing that to save on compute costs. When you start it again, AWS finds a new healthy piece of hardware in its data center and just places your instance there.
Okay, that makes sense from a resource management perspective, but what does that do to my addresses?
Well, your internal IP address stays the same.
Okay.
It's tied to your instance. But your external public IP address will be completely different.
Wait, what? It just changes? Why?
Because that public IP was associated with the old piece of hardware.
Oh, wow.
The new hardware comes with a new public IP from AWS's massive pool.
That seems like a huge problem. If my website's domain name, mycoolwebsite.com, is pointed to that IP address,
Right.
the moment I restart my server for a simple update, my entire website becomes unreachable to the world.
You have just described the exact panic-inducing scenario that every new cloud user experiences.
Ugh.
And the solution is the hero of our story today,
Okay.
the elastic IP address.
An elastic IP. It sounds elastic, but also permanent.
It is. Think of it as a static public IP address that you reserve for your own account.
Right.
You own it, and then you point your domain name to this elastic IP one time,
Okay.
and then you can attach that IP to any EC2 instance you want.
Oh, I see. So if my main web server fails or I need to take it down for maintenance, I can just launch a new one.
Yeah.
And then in seconds, I reattach the elastic IP to the new healthy server. The public address the world sees never ever changes.
Exactly. It completely masks the failure.
Wow.
It decouples your public identity from the underlying disposable server. That's not just a convenience, it's a
Right.
fundamental pattern for building highly available and resilient applications in the cloud.
That's the real magic. So are there any catches? Is it expensive?
Not at all. With a clever rule, an elastic IP is completely free as long as it's attached to a running EC2 instance.
Okay.
However, if you have one just sitting in your account unattached, AWS charges you a very small hourly fee.
Why would they do that?
To prevent people from hoarding them, public IPv4 addresses are a finite, scarce resource on the internet.
Right.
The fee encourages you to release any addresses you're not actively using, which is good for everyone. It's a use it or lose it policy.
That is incredibly smart. It promotes good architectural hygiene. So to recap, dynamic public IPs are the default.
Yep.
But for any stable endpoint, a web server, an API, anything the public needs to reliably find, you absolutely need an elastic IP.
Now, here's a question we'd like you to think about. An elastic IP provides a stable public identity,
Okay.
while the hidden machinery behind it can change, upgrade, or be replaced at any moment. Where else in your life or work do you see this powerful pattern of a stable interface masking a dynamic and constantly changing backend?
Okay, let's pause there. That was a pretty deep dive into networking. I think we know quite a bit about EC2 now.
Yeah.
And, more importantly, how to connect things together securely in your VPC.
My brain is definitely a little bigger. It feels so good to have that foundational piece, locked in. So what's the next block we're building?
The next logical step,
Okay.
and it's a huge one, is storage. Now, we've mentioned S3 a few times.
Right.
And we will definitely go deeper into that.
Mm-hmm.
But there are several other critical ways to store data in AWS.
Oh, okay. So it's not just like one giant hard drive in the cloud. What are we talking about?
Right. So we're going to spend ample time covering S3, of course, but also EBS, which is like the hard drive for your server, EFS for shared file systems,
Wow.
and we'll even touch on the world of databases.
Wow. Okay, and I'm guessing that for anyone studying,
Oh, yeah.
that sounds like a list of things that will absolutely be on the exam.
You can bet on it. It's a core component.
Right.
So we'll make sure we cover it well. We really look forward to tackling that with you on the next one.
We do. And if you, our awesome listener, think this content is useful, please help us help you. No, but seriously, take a moment to like, comment, subscribe, share this with someone you think might enjoy it.
It really does. It makes a huge difference.
Yeah.
And as always, our most important piece of advice is, remember to get some hands-on experience. Sign up for that free tier and just start building.